Hi everyone, and welcome to another video on our series of videos for chemistry revision. Today we're going to continue to focus on oxidation states, and this time we're going to talk about a little bit more complicated examples of determining oxidation states. Okay, so let's warm up first before we do anything complicated. So let's do sodium chloride. Okay, sodium chloride, straightforward. We know that group 1 metals usually have an oxidation state of +1. Chloride ion, Cl minus, usually -1, which will give us an overall oxidation state of 0. Straightforward. Okay. Carbon dioxide. Which element do we assign first? Carbon or oxygen? So typically, oxygen does not change its oxidation state very often. Typically, it has an oxidation state of -2. Since there's 2 oxygen, we multiply by 2, giving us -4, which has to be balanced with the +4 in order for the overall oxidation state to be 0. Therefore, carbon here would have an oxidation state of +4. Okay. Now, potassium nitrate, let's take a look. Which element do we assign first? There's 3. Potassium, nitrogen, oxygen. So let's do potassium, because potassium group 1 rarely changes its oxidation state. It would have an oxidation state of +1. Next, we would assign oxygen, typically -2, but there's 3 of them, oxygens here. So we multiply by 3, giving us -6. Now, because the overall oxidation state has to be 0, because the oxidation state of a compound is 0, this -6 would have to be balanced with a +6, which means since potassium is an oxidation state of +1, nitrogen must have an oxidation state of +5. Okay, so those are the warm-up examples. So now let's take a look at magnesium nitrate. Now we have a compound with brackets. So can we use the same method? Okay, let's see. Magnesium, nitrogen, oxygen. Which element would we assign the oxidation state first? Okay, typically magnesium group 2 doesn't change its oxidation state much. It would have an oxidation state of +2. Nitrogen and oxygen, typically we would assign oxygen first. -2 oxidation state. Now, how many oxygens are there in magnesium nitrate? We can say that it is 3 times 2. So we have to multiply by 6, giving us an overall -12 here. Now, since we know that the overall oxidation state of a compound must be 0, okay, so the nitrogen must contribute positive or +10. Okay, so that the +2 and the +10 will give you +12, which will cancel off the -12. So since there's 2 of nitrogen, we have to multiply it by 2. So the oxidation state of nitrogen here has to be +5. Okay, now there's 2 of nitrogen here because NO3 bracket 2. So there's 2 nitrogen, we multiply it by 2. Okay, so let's do something a little bit more involved. Now we look at ammonium nitrate, NH4 to SO4. There are 4 different elements: nitrogen, hydrogen, sulfur, oxygen. Okay, so which element would we assign first? Okay, typically let's go hydrogen. Hydrogen, oxidation state +1. How many of them are there? 4 times 2. So there's 8. Overall, +8 or +8. Next one, let's go oxygen. Usually -2. How many oxygens are there? 4. Overall, -8. Okay, so the hydrogen +8. The oxygen, -8. Now, we may come to the wrong conclusion that since the overall oxidation state of ammonium sulfate has to be 0, and the +8 already balances off with the -8, we may conclude that sulfur would have an oxidation state of 0 and nitrogen would also have an oxidation state of 0. But that would be wrong, okay, because this is not the correct way of calculating the oxidation states when there are a lot more complicated, when the formula is a lot more complicated. Okay, so is there an easier way to determine the oxidation states of nitrogen and sulfur here? Okay, now there is. The simplest, most effective way of determining the oxidation states here would be to think of ammonium sulfate as an ionic compound. Okay, so ionic compound ammonium sulfate is composed of ammonium ions, since there's two of them, and a sulfate ion. Okay, now when we are calculating the oxidation state of the individual elements, we don't have to worry about the fact that there's two of ammonium ions. Now, of course, this will give us a total charge of 2 plus. The charge of 2 plus will balance off the charge of 2 minus. Okay, but now we are calculating oxidation states, so we focus on the ammonium ion. Now, let's assign oxidation numbers. Hydrogen plus 1, 4 of them times 4, overall plus 4. Now, what would be the oxidation state of nitrogen? Okay, keeping in mind that the overall oxidation state of the ammonium ion must be plus 1 because it has to match with the charge. So, nitrogen here would have an oxidation state of -3. Okay, because -3 plus 4 will give you plus 1, which corresponds to the oxidation state of the ammonium ion, which is a plus there. Okay, so let's take a look at the sulfate ion. We would assign oxygen first, -2. There's 4 of them times 4, giving us -8. Okay, and because the sulfate ion would have to have an overall oxidation state of -2 to correspond with a charge of 2 minus, that means what would be the oxidation state of sulfur? It would have to be plus 6, okay, in the sulfate ion. And you can see here that the oxidation state, okay, so this is the oxidation state of sulfur in the sulfate ion. So you can see that whenever you have a complicated ionic compound or complicated formula, in this case it is much easier for us to split the whole formula into its individual ions, and then from there, keeping in mind that the overall oxidation state of the ion must correspond to the charge, it's much easier for us to find the oxidation states of nitrogen and sulfur here. Okay, so this gives you a simpler way of finding the oxidation states of more complicated looking compounds. Okay, so before we end, let us take a look at a few more examples of oxidation states of transition metals. Now we know transition metals typically like to change their oxidation states, and different oxidation states actually correspond to different colors of the compounds. So let's take a look at iron 2 sulfate. What do you think the 2 here corresponds to? Yes, it would actually be the oxidation state of the iron in iron 2 sulfate. So whenever you see iron 2 sulfate, you would know automatically that the oxidation state of iron is positive 2. Okay, now this makes sense because we know that in iron 2 plus, it is Fe2 plus joined together with SO4 2 minus, and 2 plus would definitely have an oxidation state of plus 2. Again, here I emphasize, when we talk about charge, we use number and then sign. But when we talk about oxidation states, we use sign and then number. Okay, don't mix up the two. Now let's take a look at iron 3 chloride. Automatically, you can say that the oxidation state of iron here would be plus 3. Okay, and it's quite easy to see that if we put the oxidation state of chlorine here as negative 1, and since there's 3 of them, it'll give you a negative 3, balancing the positive 3 from the iron to give us an overall oxidation state of 0. Okay, again, copper 2 nitrate simply means the oxidation state of copper here is plus 2. Okay, now let's take a look at two other compounds. Potassium manganate 7. Do you remember what is the color of potassium manganate 7? Yes, this is a purple solution. It is an oxidizing agent. What do you think the 7 here refers to? Would it be the oxidation state of potassium, manganese, or oxygen? Well, it makes sense that it would be the oxidation state of manganese. But let's take a look. Potassium, group 1, plus 1. Oxygen, usually negative 2. There's 4 of them, times 4, giving us negative 8. Overall has to be 0. So plus 1, negative 8. Therefore, the manganese would have to have an oxidation state of plus 7. And therefore, giving us the name manganate 7. Okay. Potassium dichromate 6. Potassium, chromium, oxygen. Naturally, the 6 would refer to the oxidation state of chromium. Is that really true? Let's see. Potassium plus 1, 2 of them times 2, giving us plus 2. Oxygen, negative 2 times 7, negative 14. Overall oxidation state of a compound has to be 0. Therefore, the chromium must give us plus 12. And because there's 2 chromium, each chromium must have an oxidation state of plus 6, which corresponds to the name of the compound, potassium dichromate 6. 6 meaning the oxidation state of chromium in potassium dichromate. Okay, so I hope this simple exercise gives you a little bit more in-depth knowledge on how to determine oxidation states of transition metals as well as a little bit more complicated ionic compounds. Okay, so hope that you learned something from this video. Right, thank you. See you in the next video. Bye bye.